All right, in this video, I'm going to first go over how to compare the circumference of two different circles, and then I'm going to go over how to find the area of composite shapes. So let's start with this question. The radius of a baseball is 70 millimeters. The radius of a soccer ball is 245 millimeters. What is the approximate difference between the circumference of the baseball and the soccer ball? Round your answer to the nearest millimeter. So they want me to find the difference, which means subtract, of the two circumferences. So I'm going to find the two circumferences first. I'm going to do all my work for the baseball over here and all my work for the soccer ball over here. And the circumference formula is circumference is pi times diameter, which I remember as cherry pie is delicious. All right. The only problem is you need to plug in the diameter, and they gave us the radius of each, the baseball and the soccer ball. So over where they said the radius is 70 millimeters, I'm just going to multiply that by 2 and say the diameter is 140 millimeters. And over where they say the soccer ball has a radius of 245 millimeters, I'm going to multiply that by 2 and say the diameter is 490 millimeters. All right, now I'm ready to start. So for the baseball, I'm going to plug in the diameter, pi times 140, and I'm actually going to leave that as 140 pi for now. For the soccer ball, I'm going to plug in the diameter, which is 490, and I'm actually going to leave that as 490 pi for now. Now, I found both the circumferences. They're still in terms of pi, but I'm going to find the difference of them here before I start rounding. So I'm going to go, okay, what is 490 pi minus 140 pi? And I get 350 pi. Then I'm going to plug that into my calculator. So here I go. Okay, 350 times pi. And remember that you might have to hit this button to turn your answer into a decimal. I'm going to write down all of the digits that are on my calculator before rounding them, except the last digit. And it says round to the nearest millimeter. So here's the nearest millimeter. I look over, 5 or above, give it a shove. So, I really have to round this one. Okay, so the difference between the circumference is 1,100 millimeters, about. Interesting. All right, now let's go over how to find the area of some composite shapes. Now, composite shapes are more complex shapes, but they're really made up of basic shapes. So it's easy to find the area or the circumference of them if you break them up into the familiar shapes that you know. So this says break up the composite shapes into familiar basic shapes and then find the area. Label with the appropriate units round to the nearest tenth when appropriate. So I see two familiar shapes here. I see a semicircle, and I know that to find the area of that, it's a half pi r squared. And I also see a rectangle. This is not a square. The sides are not the same. So to find the area of that, I'm going to do length times width. So let's see. I'm finding the area of this semicircle. I need to know what the radius is. And they don't have it labeled, but they do have this line segment labeled as 25. So that means that this diameter of the semicircle is 25 centimeters. And we need the radius, which is half of that. So now I know the radius is half of 25 is 12.5 centimeters. So now I can start solving for the area of this semicircle. Area equals a half pi 12.5 squared. Now on my calculator, I'm going to do this part first. 12.5 times 12.5, and I get the area equals a half times pi times 156.25. Then I'm going to multiply this by a half, and I'm going to have the area equals 78.125 pi. And I'm going to leave it like that for now. This is the area of my semicircle. Now the area of the rectangle, I just do length times width. I wrote it down twice for no reason, which is 25 times 20. 25 times 20 is 500. So this is 500 centimeters squared. So now I have to add these two areas together. So I'm going to do 500 plus 78.125 pi on my calculator. So I'm going to do 500 plus 78.125 pi, and I get 745.436926. And it says round to the nearest tenth. So I cut this off at the tenths place. It's 4 below, so I let it go. The whole area is approximately 745.4 centimeters squared. All right. So again, here, let me just adjust. I found the area of both of my basic shapes and I added them together. So let's do the same for my shape over here. So this looks like, I don't know, like an L kind of, but I'm going to make it into two shapes that I'm very familiar with, rectangles. So I could either cut the L here, or I could cut the L here, and I could make two rectangles. So I'm going to cut my L right here. It's just a decision I made. And I can find the area of this rectangle pretty easily because it's 5 times 3. So I'm going to write area equals length times width, area equals 5 times 3, area equals 15 feet squared. Now, I have to find the area of this shape. Now, I'm not going to do 6 times 2 because I only want to find the area from here to here times 2. So you have to find out what is the length of this. Well, I know that the length of this is 3. And I know that this whole length is 6, which means the length of this side must be 3. So if I'm trying to find the area of this rectangle, I could do area equals length times width, area equals 3 times 2, area equals 6 feet squared. And now to find the area of the whole shape, I know that this is 15 feet squared. I know that this is 6 feet squared. So I'm just going to add them together. 15 plus 6 is 21 feet squared. I hope this was helpful. Please see me if you have any questions.